So here the question is, if I ask you to write a KVL in this loop, right? This is the loop. In this loop, if I ask you write a KVL in this loop, what we write? Like V1 equal to I1 R plus L voltage across the inductor di1 by dt. Because of this is the I1, because of this I1 is a time varying current. If a time varying current flows in the inductor, magnetic flux will be produced in the inductor. Is because of this alternating current, this is a changing current. If a changing current flows in the inductor, a magnetic flux induced. This is the pi1 induced. Because of this magnetic flux induced, an EMF induced in the inductor. We know that the flux linkage, let us say psi equal to, this is the flux linkage, that equal to number of turns in the coil into the flux produced. That is called the flux linkage. That is equal to L into I. The flux linkage increases if I is increased. That flux linkage S psi increases if pi increased. So from this, L equal to N into pi by I. This is formula for L, coefficient of self-inductance. But EMF induced because of this flux phi1, because of this flux phi1, an EMF induced. What is that EMF induced here? Here an induced EMF. EMF induced here is minus d by dt of n pi, but n pi equal to Li minus d by dt of Li. From this you can write minus L di by dt. This is induced EMF, right? This negative sign indicates a Lenz's law. I will tell you how it came. Okay. So, but in writing the KVL equation, that is the induced EMF. Induced EMF is nothing but that is the induced voltage. But in writing a KVL, here V1 equal to I1 into R, L dim I1 by dt, that's okay. But here we are not writing minus here, we are writing plus, right? Why? That is the question. For that, I'm going to explain the things here. First, I have an inductor. This is an inductor. For this inductor, let us say this is R, and we are applying a voltage V plus minus. Because of this, some current I1 flows. Because of this I1, this is the I1 direction. We'll write this is I1, right? I1 direction. This is I1 direction, right? So because of this I1, a flux induced, a flux produced, correct, would say, a flux is produced in the inductor. That is given by the right hand thumb rule. Okay? So if you place your four fingers, right? So you place your all four fingers of your right hand in the, if you fold these four fingers in the direction of the current, then you will get the direction of the magnetic flux produced in the coil. This is the magnetic flux produced by using right hand thumb rule. Okay, let us say this is phi1. Okay, now from this, the flux linkage psi equal to number of turns into pi1, that equal to L into I1. Okay, this is the relation. But what happens if initially I haven't, suppose initially an inductor is there, I haven't supplied any current initially. Initially my inductor is like this initially. I haven't supplied anything, any alternate current. Now here I am trying to supply I1 here. Suddenly some I1 current is I'm supplying here. But what does an inductor do? It won't allow this current initially. Why? This is like inertia. uh, I will explain this. Suppose suppose a truck is there. Okay, suppose a truck is there. If we want, a truck is there at rest. Okay, if we want to push this truck, okay, manually. Okay, we want to push this truck manually. Will it move? It will not move. That is, we are applying a force F, let us say, in this direction, but it is not moving. It is still at rest only. So how can we see this? If we are applying a force in this direction, right? That is, this this truck also applies the same equal and opposite direction. Then the net force becomes zero, so that the truck will remain at rest. It will not move, right? So this is called inertia, moment of inertia. This is because of mass. Mass has moment of inertia. If I apply a force, it always opposes this force, right? It always opposes this force. Uh, if we are trying to apply a force, the truck always opposes the force we are applying here. Okay? So this is what happens here also. The two equivalent and opposite force is applied here because it is in rest. If a body is at rest, it always trying to be at rest only, unless otherwise if we apply a greater force. Okay? So here also in the inductor also, initially we are not applying any current. Suddenly we try to apply some I1 current here. Okay? Suddenly we're trying to I1 current. Suppose if I1 flows in the circuit, the flux produces in this direction. This is the circuit flux produced. But this inductor will not allow. This inductor does not allow this kind of changes in that inductor. What it will do? It also opposes, like it also opposes, like this is the pi 1, this yellow one is pi 1. So this inductor will try to oppose it, right? By this is the direction of, it will oppose in this direction. So this is a pi 1. So it will oppose means, so exactly equal and opposite flux produced. This is the direction of the flux. Okay, it will oppose. That is, in order to produce this flux pi 2, let us say this is pi 2. This is in the direction of upward direction. So in order to produce this pi 2 in upward direction, current has to move in this direction, I, I2, let us say. Okay? And we are not applying anything to the inductor, but we suddenly applied some alternating current I1. So this will not, so then the inductor always tried opposite by making equivalent opposite flux going through it. Okay, by making an equivalent opposite flux produced in the inductor. How it happens? Initially, we haven't applied any current to the inductor. Suddenly, we applied I1 current. But these changes, these sudden changes, current will not allow. What it will do, in order to oppose this current, or in order to oppose this flux produced pi 1, it will produce some pi 2 in the opposite direction. The two equal to the two equal in magnitude, but exactly opposite in direction. So here the pi 2 induced is equal to minus pi 1, right? And I2 also the same direction. I2 also magnet same in magnitude, but opposite in direction. I1 is in downward direction, I2 is in upward direction. So I2 equal to minus I1. This is the property. This is by nature, right? So this inductor always trying to oppose it. So to oppose it, in order to oppose it, this I1 current, it will produce I2 current opposite to that I1 current inside it. In order to make it zero, so this I2 is exactly equal in magnitude but opposite in direction. Similarly, in terms of flux, because of this initially I1, flux pi 1 is produced in the downward direction. But in order to oppose this, a pi 2 flux will be produced in the upward direction. But in order to produce this pi 2 flux in the upward direction, a current must be there because the flux must be produced by the current. So in order to produce this flux in the opposite in the upward direction, current must move from downward to upward direction by using the right hand thumb rule. This is the concept actually. Okay. So from this, in the second case, this is I2. Initially we applied I1, suddenly I1, but what happens in the inductor? I2 will be produced in the equal in opposite direction to I1, I2. Because of this I2, some flux produced in the upward direction. This is pi 2. This is pi 2 that is exactly equal to minus pi 1, equal in magnitude and opposite in direction of the pi 1, right? Here the EMF is how to calculate EMF here, because this is a passive element, inductor is a passive element. I'm assuming that, and current is induced in this inductor like this I2 in this direction, right, upward direction. Then what I'm assuming that this is the passive element, the induced current is I2 in this direction, then the induced EMF also will be like plus and minus. I'm assuming like this, plus minus, because it is a passive element, current should be enter at positive terminal for passive element. I'm assuming like this. So this is the induced EMF. That induced EMF is actual formula of EMF is actual formula of EMF is d psi by dt. Psi is this psi. Okay. Psi is flux linkage, but here EMF is d by dt of n into pi. But here n into this is pi 2. What is the flux induced? Induced flux. Induced EMF is due to induced flux. This is pi 2 induced flux, and that equal to n d pi 2 by dt, right? And n d by dt This pi 2 is exactly equal to minus pi 1, that I already told you, that equal to minus n d by dt of pi 1. N into pi equal to L into I, but here n into pi 2 equal to L into I2. So EMF equal to d psi 2 by dt, that equal to d by dt of n pi 2, that equal to d by dt of L I2. From this relation or from this relation, from both the relations you can get d by dt of n pi 2 equal to minus pi 1, it is minus d by dt of n pi 1, but we know n pi 1 is L I1. So from this relation, minus L into d I1 by dt, or from this relation d by dt of L, where I2 equal to exactly equal to minus I1, right? From this relation, minus L into di1 by d2. Both the case we will get minus L into di1 by d2. Both the case we will get minus L di1 by dt. This is EMF. But the EMF, we are assuming that this inductor is a passive element, right? So for a passive element, current must be enters at positive terminal, and induced current. This is induced EMF. This induced EMF is due to induced current. This is the induced current I2. So current must be enters at positive terminal. That is why I have put positive here and negative here. I'm assuming like that. I thought that this is a positive terminal. This is a passive element, right? Now, what we got, okay? I will represent these things in the circuit. But this EMF we got is minus L into d I1 by dt. Now I will represent them in the circuit. This is V1, this R, this is I1, right? So plus minus induced EMF is minus L d I1 by dt, right? This is the induced EMF. Now write the KVL equation now. Write the KVL equation. V1 equal to I1 into R, and here a negative terminal is there. This is positive terminal, this is negative. So minus of, but what is the voltage here? EMF minus L di1 by dt, that equal to I1 into R plus L di1 by dt. That is why while writing KVL here we get positive sign. Okay, this much Ramakatha is there, but if you understand it, it is fine. If you don't understand it, that is also fine. You don't need, nobody will ask you in the exam these things. Okay, so just remember it. V1 equal to IR, in place of L you have to replace its voltage, L di by dt. This is how you remember, you write it. But keep in mind that these are the things that we also have to know, as we are electronic students or electrical students. We have to know these things, right? I hope this is clear.